So, first, just in passing, I do want to slightly say that I think your conception of mathematics is, you did say pure mathematics, is much more about a very particular kind of set theory approach that probably most working mathematicians would say, I don't do that.
Yeah.
But that's not really my question. My question is, do you think it's possible that some of these pluralist mathematics, these different mathematical universes, some of them will be ethically better than others? You know, the reason I say that is I've worked with mathematicians. I've been paid as a mathematician most of my career, and my colleagues take a great deal of comfort from the fact that the tools they use, they believe are ethically neutral, morally neutral. You know, the maths itself doesn't create problems.
Yeah.
But do you think it's a possibility that that's wrong?
That mathematics might actually have something like an ethical responsibility to...
That you should choose one mathematics over another because of its moral content.
That's an interesting, even further thought. I think it might be an interesting proposal. I think mathematicians wouldn't care very much. I mean, the experience is that mathematicians, they do their thing, and they don't care about philosophical questions. They don't care about ethical questions. They pursue mathematics in whatever way they see fit, and that's a good thing. Now, if we wanted to restrict mathematical practice out of ethical considerations, I think it wouldn't go over very well with them. One might make a philosophical case for it, but I think it would remain without any practical results. But it's an interesting idea.
Hi, yes, you stopped your mathematical story with Zermelo-Fraenkel's set theory, and I would have thought, I was expecting you to come on to what I thought was the most philosophically devastating development in mathematics since, which of course is Girdles' incompleteness theorem.
Sorry?
Girdles' incompleteness theorem. Do you have any thoughts of what the implications of that has for our perception of reality in other domains?
Oh yeah, so the question was Girdles' incompleteness theorems, which basically tell us that any axiomatic system capable of doing arithmetic is necessarily incomplete, won't be able to prove its own consistency. And that has, in fact, really revolutionized the way we understand truth, sort of more generally, because it has introduced to us the notion that the set of truths will always be larger as the set of the things we can express in language, so that proof is always weaker than truth itself, as it were. So yeah, it has radically changed the way we see reality.
You mentioned that nowadays a lot of mathematical ideas don't have any correspondence in reality, but for example, non-Euclidean geometry, many decades after it was invented, helped Einstein figure out space-time. So how do we know there won't be other correlates in the real world of any esoteric idea?
Well, that's, thank you very much. So the point is that some developments in mathematics that appeared at some point to be completely remote from our physical reality then later on turned out to have some physical application. That's of course not a total impossibility in set theory, but given that we're talking about, it's the realm of infinity and infinities of different sizes that most of these, unanswered questions arise. It's relatively unlikely that will translate back into anything that will have physical application. It's not, I don't think anybody could prove that it is impossible, but it's very, very unlikely.
Can you give me a satisfying answer on what is mathematics?
Oh, if I was able to do that, I'd probably have a very, very prestigious philosophy chair already somewhere.
I think that should be your next talk.
Thank you for the question. It is a question that has been debated for a very, very long time. What mathematics actually is. Is mathematics something that happens in our heads? Is it a constructive enterprise, or are mathematicians discovering these mathematical truths? Now, I said earlier, if you're a realist, then you're probably more on the discovery side of things and not so much on the constructive side of things. But no, unfortunately, I cannot give you a satisfactory answer to what mathematics is exactly. But I'm working on it.
When I was thinking about belief systems, I came across Lakartov's work. I don't know if you're familiar with that. And as I understand it, he suggested that mathematical theorems actually come with a defensive belt to defend them against actually the ways that they might be criticized, which is quite relevant to our own personal psychology and seems relevant to your pluralist views.
So the defensive belt would be against any sort of counter-argument. Yeah, so I think that's exactly the kind of property about the mathematical domain that has been exploited in philosophy for such a long time. I mean, allegedly, mathematics gives us this perfectly secure knowledge that once it's established, we can never change again anymore. And in that sense, I think this new pluralistic ideas that are entering the scene are so interesting because it really is shaking one of the tenets of the way we understand the mathematical realm, this absolute certainty. Yeah, thanks.
Could you say something or explain the concept of zero in relation to shunya? Because I understand it, that was what brought religion into mathematics, the concept of emptiness that came out of India.
Oh, I don't know that much about Indian mathematics in relation to religion. I could say something about oneness in relation to Plotinus's philosophy, but I'm not familiar with shunya, I'm afraid.
I think in part it's just the very idea that, as I understand the history of mathematics, which is very amateurish, it started maybe somewhere with the Egyptians and counting bales of wheat or whatever it was, and they had numbers, sort of things, real things, particles of things, which they added up, and that the concept of zero as in nothing, not as a placement holder, actually arrived from Indian philosophy, which may be a bit different from Plotinus's oneness. So it's that concept that's in Buddhism too, of emptiness, the nothing, the void.
Well, yeah, it is the fact that zero as a number was only introduced fairly late after people started using rudimentary mathematics, as it were, is a very interesting development. I agree with you on that. And so it's true that many philosophers in India, in ancient Greece, thought that there was something very peculiar about either the number zero or the number one. So I can speak more about Plotinus, who thought that number one was actually very, very fundamental, because it only if we can think oneness, we can also think plurality, and in order to sort of conceptualize our entire reality, we need the concept of plurality, but the concept of one is always the one that is fundamental. A lot of thought has gone into what the actual numbers mean, and 0 and 1 obviously are special cases, but I can't say more about the Indian case, I'm afraid. Yeah, thank you.
So you're mentioning about the question that you have there on the screen of how pluralist mathematics shape our conceptualization of reality.
Yeah, it's a terrible word.
Yeah, it's a big one.
Sorry.
And you're probably focusing on perhaps these developments in set theory as the source that is going to perhaps create these changes in the way that we conceive reality. However, I think that perhaps even from the point of view of applied mathematics, there might be changes that can contribute to that particular question. And I'm thinking in the way in which we use mathematical models to tackle problems in empirical sciences, which typically at some point, a lot of times, end up in setting up a set of differential equations that you solve. But now we are moving, perhaps, or we're starting to move away from that paradigm in which we construct specific models with a very specific functional relationships between different variables to something in which data, it's speaking by itself. And I'm specifically thinking about like neural networks and things like that. Have you considered, have you thought your question in terms of the contributions that may come not from the pure mathematics, but from applied mathematics, which at the end are the ones that are in constant interaction with the empirical science?
Thank you. So the question is, does this have any consequences for applied mathematics, specifically for the way we use mathematics in order to model all sorts of things in the empirical sciences and the social sciences, etc. I think there won't be any straightforward direct consequences for those areas. And the reason is that, so I mentioned this set theoretic pluriverse or multiverse, and all of our standard mathematics, arithmetic, algebra, etc., that all remains the same. So the pluralistic split, the splitting up in different sub-universes is something that is happening at a very, very abstract level within set theory. It doesn't affect all the theorems of, well, the conventional areas of mathematics. And in that sense, it also won't affect mathematical models. So I think, if anything, the results are going to be most palatable really in philosophy, where we reason about mathematics on a much more abstract level and not by application of mathematical models. Thank you very much.
For more debates, talks and interviews, subscribe today to the Institute of Art and Ideas at iaitv.